So what is happening with algae in the lakes of Canada? How has climate change impacted? Hello friends, Jim here. Climate change is driving major algae surge in Canada's lakes, a recent study finds. We'll get back to this figure later on. Algal growth is accelerating in lakes across Canada, including those that are considerably distanced away from impacts of human development. The new study shows that climate change is the primary driver. A research team led by scientists at McGill University and Université Laval examined lake sediment cores from 80 lakes across Canada to uncover long-term changes in algae levels. The study, published in Communications, Earth and Environment, shows a significant uptick in lake algae production since the 1960s. Over the past 150 years, we've seen algae levels rise in most Canadian lakes. But in the 1960s, algae levels accelerated dramatically, increasing at a rate 7 times faster than before, said Irene Gregory-Eves, who is a co-author, biology professor at McGill. What was most surprising is that this happened even in remote lakes far from any immediate sources of human pollution or development. To identify the cause of these changes, the team combined the study of natural archives, basically lake sediment cores that go back into the 1800s, with machine learning techniques to detect long-term trends. They then compared those algae records with historical data on air temperature, solar radiation, and nearby human activity. Our research points clearly to climate change as the primary driver of the algae dynamic, said Dermot Antoniades, who is a co-author and limnology professor at Université Laval. As climates warm, lakes are getting warmer too, which create ideal conditions for algal growth. Other factors such as solar radiation and land use played a role, but warming was the strongest influence. Previous studies looked at few lakes or shorter time spans, often linking algae growth to local pollution such as fertilizer runoff. Our research shows something larger: climate change. Specifically, rising temperatures is the main driver, even in remote lakes with no nearby human activity, said Hamid Ganbari, who is the lead author of the study, as well as a postdoctoral researcher at Laval. This is an issue everyone should be aware of, the researchers say. Lakes are places where we swim, fish, drink water, and run business, said Antoniades. When algae grow uncontrollably, it can harm our health, kill fish, stink up beaches, and cost money. Our study shows that local fixes alone, such as reducing fertilizer runoff, aren't enough anymore. Climate action is essential for protecting lakes in the long run. Healthy lakes mean healthy communities, Ganbari said. Ignoring these issues results in greater risks to our water, wildlife, and wallets. Okay, so I have a few thoughts, as you could imagine, but first, let's take a look at this figure here. So this shows the location of the 80 study lakes and their chlorophyll trends between 1850 and 2014 CE. And this comes from the research paper that was referenced. So you see various things like LO6, LO7, LO8, LO9, 10, 10, 11, 12, 13, 17, 18. So you know the indicator here on the maps. Okay. And blue indicates a decreasing trend in algae growth. red is increasing, black was no trend. And really, just a couple of places right here, here, and here, basically in Quebec province, that showed no trend, neither increasing nor decreasing. So as we can see, there's a lot more that is increasing than those that were decreasing. So this shows you. Now it's not, you didn't get into the Northwest or Nunavut territories. You didn't get into, here's, for example, they looked in Newfoundland and Labrador, and get up into northern Quebec or even in northern the prairie provinces and so on. So, and it could be the conditions, whether lakes are present or not. But don't forget, you've got the Great Slave Lakes and Great Bear Lakes. You got a whole bunch of lakes right in this section of Canada where you can do some. Like near Yellowknife and so forth, they could have done sampling. But looking at the distribution with a couple of, it's like, say, in, that almost looks like, northern BC, Yukon territory. Most of it is the lower, the southern portions of the country. So now the questions that I have are, what kind of lakes were sampled? Were they dimictic lakes? Were they monomictic? Were they meromictic? Okay. Were they even amictic? Now, mictic refers to the kind of mixing. Most temperate lakes are what's called dimictic. You have a autumnal overturn, followed by winter stratification. Then you have a spring overturn, followed by summer stratification. Two mixings, right? Monomictic, you just have one mixing a year. Amictic, there's no mixing at all, permanently stratified, or could be permanently homogeneous from top to bottom. And usually when we refer to dimictic or monomictic, it's the entire water column that overturns. Meromictic is a mixing of the lake that is incomplete. In other words, it does not overturn the entire water column, so you end up very likely resulting in an anoxic layer near the bottom. Now, in my Let's Talk About Stratification video, I discuss all of this. So you may want to check out that video. So they're obviously looking at the growth of algae. Now, this causes problems because then, yes, they're doing photosynthesis to grow, increase their productivity, but don't forget, plants also respire. So if you have this burst in biomass, you're going to what's called increase the biological oxygen demand, the BOD. And when that happens, the DO levels, dissolved oxygen levels, decrease. And that's not good for fish, having lower oxygen levels, especially in cold water locations. Because typically, remember, the colder the water temperature is, the more oxygen it can hold. And a lot of fish that are found in cold water lakes and rivers, they require a higher oxygen content. That's what they evolved to. So that's going to put a stress on them. Also, with the increase in water temperatures as cited, well, then that also decreases the solubility capabilities of the water. So you have warmer temperatures that decreases the gas solubility, so that lowers the oxygen level. And you have increased biological oxygen demand, also further lowering the dissolved oxygen level that's available to heterotrophic organisms. So, most people look at this headline and go, "Oh, wow, this sounds good." No, not really. It's not good. It can have dramatic impacts, negative impacts on the local ecosystems. So here's yet another example of the impacts that humans are having, the unanticipated, unexpected ramifications of what we've been doing to the planet for the last 250 to 300 years. So, now the question becomes, what's the trend for U.S. lakes? What's the trend for lakes up in Alaska? Other parts of Canada's north? What happens in lakes, say, in Scandinavia, Northern Europe, Russia? In other words, worldwide. We need to start looking at this and see what's happening. So, more concerning news. We'll talk soon.